go through tutorial 6 and let's have some fun. Differentiation so easy, okay? This is amazing and let's enjoy. Now, what do we have as our number one? They're saying find y prime. Remember, these are just notations, okay? This is to just, if I have y and they ask me for y prime, remember, look at y prime, forward slanting, okay? This is to say the first derivative. If we say y prime prime second derivative, we know that if we had f of x being equal to something, we would say please find f prime of x, okay? Which is the first derivative. If we now say f prime of 3, we mean first find the first derivative, which will be f prime of x. Then after that, put 3 in your solution and see what it would get. So here we know that these notations, we are fine with them. Now here, let's go through this. It says find y prime. So what do I have? In other words, just differentiate, find the first derivative. So in number one, I have y being equal to cot x all over 1 plus cot x. And I'm supposed to differentiate this. So what is it that I need to know for this one? Well, number one is, don't try to separate to say, oh, this is going to be equal to y, or y is equal to cot x over 1 plus cot x over cot x. This is wrong. Do you know why it's wrong? Do you know why this is wrong? You can never split the denominator this way. This you can only do if it was the numerator which had two things. Okay, to say if it was 1 plus cot x or over cot x, then we could have split it, okay? Because the numerator we are allowed to split, it would have been 1 over cot x, then plus cot x over cot x. But not denominators. You don't split denominators, so it's out, okay? Because here the denominator is the one which is two parts. So here we can go back at the saying we have y is cot x over 1 plus cot x. So there is no way to split the fraction. So we are stuck with this fraction. So we have to differentiate it as a fraction. Now, how do we differentiate fractions? You use the quotient rule. Remember, when we are differentiating fractions, we use the quotient rule, right? When we are differentiating things that are dividing each other, quotient is to divide. So what would we need to know? We need to know, number one, the quotient rule. And then two, we also need to know how to differentiate these trig guys. Cot is a trig. Remember, for trig, we have sine, cos, tan, cot, cosec, and sec. Now we need to be able to differentiate them. And what do we use to differentiate them? We use the common derivatives table. It tells us the derivatives of strict things. So before we answer this, let's put those two things and then we can be able to answer. What are the two things we got to put? Number one is the common derivatives table. Common derivatives table just tells us the derivatives of trig. Okay, we go knowing already, we should already know the derivatives of trig, guys. We start with sine x, then after is cos x, then after is tan x, okay? Then after we can say sec x, then after is cosec x, which we can just write as CSC, or you can write it as cosec x, then cot x, okay? Now we want to know what are the derivatives of these things. What is the derivative of sine? It's cos x. What is the derivative of cos? It's negative sine x. What is the derivative of tan? It is sec squared x. So tan and sec squared are related. Then tan and sec are related because if you now want the derivative of sec, it will be sec x tan x, okay? Tan gives you sec squared, but sec can't give you tan x. Tan squared can't give you tan squared. It will give you sec x tan x, okay? And that's the same for cosec and cot, okay? Because if you start with cot gives you, what's the derivative of cot? It is cosec squared x. So cot is like tan. They are very related. What tan does is what cot does, because cot is 1 over tan. Okay, we should know what each of them mean, and then we should know their derivatives. So here, what is the derivative of cot? It's like tan. Tan is sec squared, so cot will be cosec squared. And cosec will not be cot squared, but it will be cosec x, then cot x, just like this other one did, eh? And then now for these C guys, you should put negatives on both of them, the cot and the cosec, and you'd be done. This is your common derivatives table. You should write it over and over again. You start with sine, you go to cos, you go to tan, you go to sec squared, because tan should give you sec squared. Sec can give you tan squared. It will give you sec x tan x. Then cot will give you cosec squared. Then cosec will give you cosec cot. But they should be negative in front. They should be negatives. Now, what is the other thing? We need to know the quotient rule. Now, when you have two things dividing, if y is equal to ub, so you can see if y is equal to u over v, which is that you have two functions that are dividing, two things that are dividing, then how do I find my dy dx? My dy dx is equal to, remember, low d high, so it's v u prime, minus high d low, which is, remember that u is the high because it's the one on top, then v is the lower, so it's low d high minus high, which is u, d low, which is the derivative of the low, which is derivative of the bottom, v prime, over square the bottom, so over v squared. Remember, it's low d high, low is v, d high derivative of the top, minus high u, d low, which is derivative of the bottom, over square the bottom. This is going to be it. And here is your quotient rule, and these are the things we need to answer this, and we'll be done. So I'm not going to start answering in the next video where we get to it. Goodbye for now.